We are on the Kaggle website, and we have loaded a data analysis of Titanic passengers who lived or died. And we will use this to create a machine learning model using the random forest algorithm. But step one is clicking the big blue button on the top right. That will create a copy of that activity and store it in your area, your account in Kaggle. It takes a few moments for this to load and be configured for you, and here it is. So let's take a look at what we have. So first, we'll be loading data files and checking that data. Second, we'll do an exploratory analysis using some of the graphic tools you learned in the last module. Next, we'll create some new variables by combining existing ones and teasing information out of others and analyzing the refined model. And with the data now configured to be compatible with the random forest algorithm, we will create a machine learning model using the training set from the Titanic passengers. We will run that and test its accuracy. Then we will run a test data set through this to see how well our predictions are working. To load what we need, the Kaggle notebook groups our commands, our statements, in blocks of a gray background and a blue line down the left. When you execute one block, they all are run at a time. First, we load a bunch of libraries, and you see our friend ggplot2 here. We load the random forest algorithm. For loading data, we'll read a CSV file into a data frame called train. That's our training data for the machine learning model. We read another CSV file in to a test file, which we'll use at the end to see how good our model is. And then we'll be combining the training and test data into one full database. We activate that by clicking the little in button. We get a blue triangle to execute the cell. We click on that. That will briefly turn to a square. When it comes back to a triangle, the block has been executed. Nothing is showing because we didn't ask it to show anything. So let's do that. Let's ask it to show the structure of the full data set. So here's our data frame with over 1,300 observations, meaning 1,300 records of real Titanic passengers, some of whom lived, some of whom died. The 12 variables are the passenger ID, just passenger 1, 2, 3, up to thousands. Whether they survived or not, as an integer, if 0 means false, 1 means true. So 0 for whether they survived means they died. 1 in survived means they lived. P class is passenger class. The most expensive and luxurious was first class. That's number 1. Then second class was next best, and the cheapest lodging was in third class. We have the passenger name, the passenger sex, the passenger age, but notice here we have an NA. Somebody didn't record their name, their age. So that's a missing value. So later on we'll see how missing values are treated in R and for machine learning. Siblings. So if you're traveling with one sibling, there'd be a 1. If you're traveling solo, that's a 0. With 3 siblings, there'd be 3. For parent and child, parch, 0 if there's no child, 1 if you have a child, 1 child, 2 for 2 children, and so on. Ticket is just a ticket number. Fare is how much you paid. From a low of around $7 for a third-class cabin up to 71 and greater into the hundreds for a first-class rich cabin. Cabin is cabin, just the cabin number. And embarked is the port. So let's take a look at a summary of the data. We click on the in, and we click on the blue triangle, and we get a summary of each of the 12 variables. Let's take a look at survived. The minimum value was 0. The maximum value was 1. Well, that's what we expected, right? So if a passenger lived, that's true, that's a 1. If they died, that's 0. They died. There are no values in between. But notice at the bottom of survived, there are 418 not available. Well, let's see why that is. Toward the top left, there's a plus sign. That will allow us to add a cell of our own to calculate something. Click that once, and a blank cell comes up here. Just click the cursor in it, and we'll use a command from last module, head, to examine the top 6 or so rows of the database. Let's look at the training database, head of train. Now, to execute this, we don't press return. We click on the blue triangle. So click on that. And here we have 6 records, and we see our 12 variables, passenger ID, whether they survived or not, and so on, their name. Okay, that's what we expected. Let's compare that to the test database. Click the plus sign, click in the field, head, and this time we'll use the test database. Don't press return. Activate that, execute it by clicking in the blue triangle. Do you see the field that's missing? In the training set, we know whether someone survived or not. In the test data set, we don't have that labeled. The label survived allows us to use a supervised learning model, which is what random forest is. Okay, let's move along to exploratory analysis. Click on the inbox. When you execute that, you'll see, oh, we're going to get a GG of the full database, but just from observation 1 or passenger 1 to 891. Those are the training databases. We're going to create a histogram with 30 bins or 30 categories. So click in the blue triangle, and we get an age versus survived. So let's take a look at this. You see that survived 0 is the reddish orange. Those passengers died. The survived blue-green 1, those passengers lived. So you can see interesting things like, gee, the 1-year-olds seemed to mostly live, right? But boy, if you were 21 or so, more of them died than lived. Okay, well, let's continue our explanation, our exploration. Now we're going to look at not the age versus whether they survived, but their sex. And we're going to look at a couple of bars. If we look at the females, did most of the females live or did most of them die? And for the males, did most of them live or did most of them die? Wow. At the time, there was a mantra for women and children first to be saved into the lifeboats. So maybe that's happening. Let's look at age versus sex. And this gives us an example of the different kinds of graphs that R can produce on demand. So here we have by age, but a separate female and male graph, and studying them, you can already hypothesize how you might predict which passengers, as they board, would not have survived the journey. Okay. Similarly, passenger class versus sex. The females on the left, and you see first class, second class, third class. Wow, if you were a first class or second class female, you were in good shape. Third class female, maybe 50-50. If you were a third class guy, whoa, not many of them made it, did they? So continuing the exploration, again, do not miss any of these because each block configures the database in some way or other. So we won't spend time on all of these, but just to see the various ways that R can display the data in ways that we can gain understandings from visualizing the image and the way it's presented as opposed to watching number after number after number. Now let's look at some data processing, how we can actually change what's in our data frames. And in this case, we have the name of each passenger, but each passenger also, or many of them, have titles. Mr. So-and-so, Ms. So-and-so, Master, Colonel. So let's see what the titles are. We're going to extract the titles. If you're a computer science teacher in high school, you'll recognize something called a regular expression here to extract that. And here we see the range of titles. Captain, Colonel, Don, Donna, Lady, Major, Master, and so on. So which of these are the most common? And maybe can we combine some of these? So that's what we're going to do. Some of the titles are rare. There's only one captain, only one Donna, only one Don, only one sir. So we're going to assign some of the rare titles to being officers, others to be royalty. If you're a mademoiselle or a Ms., you're assigned to Miss. If you're a madame, you're assigned to Mrs. Okay. So just, again, click on the N, run that, and we didn't ask it to show anything, but now let's graph those titles to see who they were. So Master is a young man. Okay. Gee, looks like more of them lived than died. Miss, wow, a lot of them lived. Mr., wow, if you're a Mr. On the Titanic, you may have been doomed. Mrs., okay, even officer, and then royalty, wow, okay. And our database includes siblings and whether parents traveling with a child, but can we tease family size from that? From the name, from the sibling, and the parent and child fields. So we're going to do some manipulation here, and we're going to plot 3 family sizes. So a family size of 1 means you're traveling solo. Wow, there are a lot of people traveling solo. Looks like only fewer than half of them survived. A family size of 2 or 3 or 4. Look at the difference between those and a family size of 5, 6, 7, or 8. Wow, I wonder what the difference is. So let's create some more variables on family size, whether someone is traveling alone, whether they're in a small family or a big family. And here again, a different kind of graph, but it shows very, very clearly, if you take the time to study it, where our groups that survived lie and which ones tended to not make it. Okay, this one just shows where they got on the boat, and that turns out to not be very important, so let's miss those. Press. Missing values. So if a passenger class value is missing, what can we do? Well, most of the passengers were third class. For the processing fair, we can replace a missing value with a likely value that most likely it's something like the median value of third class. Is it accurate? We don't know that. But otherwise, we lose all of the rest of the information in the data. Okay. So now we have looked at some fair data. If we look at the bottom, from 0 up to 70 something, and the big spike is around $7, $8, and that's third class. Okay, so it makes sense. For age, well, we can assume that, let's say somebody's a mister. Well, the average age of a mister might be 30. So if that's missing, we can replace that by the title's median. Okay, again, execute that cell, and we'll do something similar to the age of the child. And we're going to create a group called adults and children. And here we have a little table of a kind that we will look at in greater detail. According to this, there were 495 adults who died, the 0, and 279 who lived, the 1. Children, 54 and 63, who was more likely to survive, an adult or a child? And this shows us that very clearly, even though we didn't have adult and child as database variables when we began. Okay, and we can see a graph of that. Let's take a look at something called a correlation matrix. And let's not worry about how we got this. We now have a new data frame of the training data, 891 observations. Only 8 variables. We're down to that. If they survived, we don't need the passenger number. That's irrelevant. The class, first class, second class. 1 is male, 2 is female for sex. Notice all of the variables are now numeric, so they can be processed in the algorithm. Family size is 1 traveling alone, 2 small family, 3 large family. Fare is kind of unchanged. Embarked, title, there's a number for the different titles that we've created. And 1, if you're an adult, 2 if you're a child. So let's take a look at a plot of that correlation matrix. This is pretty crazy, so let's take a closer look at it. A correlation matrix compares the variables across the top with the same variables down the side. So correlation is 1 if it's a perfect correlation. Every member who survived had some other variable positive, down to -1, where let's say everybody who survived had a negative something. So the diagonal of any correlation matrix is always 1, is always top. And the 2 triangles that are created are equal. They are mirror images across the diagonal. So here we have, wow, an almost a perfect correlation between title and sex. Does that make sense? Well, if someone's a Mr., are they pretty reliably male? If someone's Mrs., right? So that makes sense. Here we have one that is pretty strongly negatively correlated, fare and passenger class. So they pay a big fare to get first class, which is a low number. They pay a small fare to get third class, which is a bigger number than 1. So these are negatively correlated, but very tightly. Okay. And whether one survived or not, we see is related to sex, is related to passenger class, not so much to embarked or whether you were a child or not. Okay, let's move right along. We have prepared the data for analysis with the random forest algorithm. We don't see any change, but it's been done. Now we're going to create the machine learning model. Okay, so we're going to split our full data frame or data set back into the training set, the first 891 passengers, and then the remaining will go into the test set. about 400 records, 400 passengers go into that. Remember, the difference is that the training set has whether they lived or died, and the test set does not. Right here, we're under set seed. RF model is where we define the actual random forest algorithm. So we're saying, okay, the random forest algorithm will use as a main factor whether they survived or not, and we will relate that to the other 7 variables. And we'll take this data from the training data set. That's all we needed to do to define the random forest model once we have the data in order. Okay, so I'm going to make sure I click on that and process it, because otherwise we're not going to get anything. So next, we're going to actually make the prediction. And this predict RF model is making the predictions from the model we just defined. So up here, we defined the model. Here, we're performing the operations. We're performing an operation on each one of the passengers, and we'll be creating about 500 trees, decision trees, that make up this random forest. So when we click on that, our prediction is that 608 passengers died, 283 lived. Let's see how accurate this was. Okay, so this is a classification. They lived or died. I mentioned the 500 trees. The overall error rate that we're seeing is about 17%. So these aren't perfect predictions, but it's better than random, isn't it? And we have a little something called a confusion matrix that shows where did we make the errors. 0 and 0, 504, we predicted, of those that we predicted died, 504 actually did. But of those who we predicted died, 104 actually lived. So that's an error of about 30%. Similarly, we predicted that 280 some would live. In fact, 238 lived and 45 died. So again, these are probabilities. The idea that this is perfectly accurate is silly. Okay, for prediction. In this case, we're going to use the same model, but with the test data set. So this doesn't know in advance who lived and who died. We're going to predict this. That's now run. We're not seeing anything. Why? Because the result has been written into a 2-column, 400-row CSV file. Where is that? It's in your working directory. So if we click on the working directory over here, we can download that CSV file and take a look at it. Okay, so here we have passenger 892 all the way to, we have about 400 passengers, and it predicts whether each one died or lived. Okay, so you have just created a model using the random forest algorithm, and you've trained it using the training set and tested it. You predicted from the test set. Okay. Now, it's possible as you go through this that you may have made some kind of error. You may have clicked someplace and then things stop working properly. Let me show you how to fix that. If you click in the K, that takes you back to Kaggle Center. And this shows you the notebooks that you've been working on. And this may be the only notebook you've worked on. If you see something else, just click on the Notebooks button up here. But if I wanted to delete this and start over, I just click Delete, notebook, and that's now gone. And when you relaunch the link, you'll be able to start over from scratch. So this is your introduction to data analysis with R using the Titanic passenger data set, creating your first machine learning model using the random forest algorithm.